Hi guys, welcome to your first day of trigonometry. This is Math 104. You've completed Math 103, and now we go on to Math 104. In trigonometry, we start with reviewing the geometry terms. Okay, just some things in geometry that we want to make sure you have the vocab, and then we're going to translate what you've learned in geometry, and we're going to be putting it on the coordinate plane. Sort of taking geometry and algebra, putting them together, okay? Trigonometry. So anyway, let's go back and review. Go back to 9th grade or 10th grade or whenever you had geometry. Okay, an angle consists of rays, two rays, and a common endpoint. Okay, the common endpoint, of course, is called the vertex. Okay, the way we label these in geometry, and you'll still see them labeled this way, this angle, we use a symbol like this, and we'll say angle BAC, or we might say angle CAB. But notice that the vertex is always in the middle, okay? Sometimes you'll even see it labeled just as angle A, okay? It's proper notation to use capital letters for the sides and vertices of angles, okay? But this is either angle BAC, somebody else might call it CAB, someone else might just say angle A, but we're talking about this angle, okay? The vertex is a point. The vertex is A. We don't have to put angle A, okay? We know the vertex is a point, so the vertex is A. The sides are rays, and then it does matter which order we write. I'm not going to say BA because that means I start at B and extend in the direction right through A. So the sides of this angle are ray AB, and I'll put a little ray at the top. I don't put two arrows. That means line AB. This is ray AB, and the other side is ray AC. Okay, so just a little reminder of that terminology, etc., as we dust off the geometry cobwebs and head into trigonometry. Okay? Like I said, we're going to be taking these angles. Here's the angle ABC again. But we're going to be putting it on the XY axis. Okay? Here's our coordinate system, our XY axis. All right, we're going to be asked to do this, and if you had notes, you could write this down, but you don't really have to. It's very important, this next part, okay? Unlike here, where we could say, you know, BAC, CAB, whatever, it's the same angle. That is not true here, okay? We have to designate which is the initial side of our angle and which is the terminal side of our angle. Where do we start and where do we end up? And we show that by drawing an arrow from the initial side to the direction of opening. Okay, I started with BA right on top of BC, and I moved BA up 54 degrees. Okay, we are going to have to get used to and recall that we're at 0 degrees here, the y-axis. If I would open exactly up to the y-axis, that would be 90 degrees, etc. We'll be talking about that shortly here, but I just wanted you to realize the difference between the ABC angle in geometry, BAC angle in geometry, and I did switch the vertices, and the ABC angle here in trigonometry, where we're going to be on the coordinate system. Okay, this angle happens to be in the first quadrant. We'll be in all the different quadrants as we go through trigonometry. Okay, initial side, terminal side. A positive angle is when I start at the initial side and I go in a counterclockwise direction. Counterclockwise will show a positive angle. Otherwise, I start on the positive x-axis if I go in the clockwise direction, it's a negative angle. For me, I don't know. I don't really think of it as clockwise or counterclockwise. I'm always like, I'm thinking to myself, well, I know that in quadrant 1 and 2, you know, those are positive y values, right? So if I'm opening up towards the positive, I just kind of, this is a positive angle. Maybe here, all right, I know that's a positive angle. I also know that if I start here and I go this way, I'm going into the negative y values, you know, so I'm like, oh, okay, this is a negative 50 degrees or whatever. Okay, that just means I started, we always start at the same spot on the positive x-axis, okay? And then we either go in the positive direction, counterclockwise, or the negative direction and have a negative angle. Okay, and that's why this new symbol is so important, you know, to include. We have to know the direction that you're opening, okay? Because maybe if I didn't have this arrow here, which, oh, it's already on there, but I might think we're talking, sorry. I might think we're talking about this angle. You know, I have to show which angle I'm talking about because I kind of have two different angles for each of these ACB sides, okay? All right. The most common unit for measuring angles is the degree. We're going to get into radians in trigonometry, of course. It's the more mathematical way of measuring angles. But the most common unit of measures in everyday life is a degree. All right? We already know that a circle has 360 degrees. Okay, so a complete rotation of a ray, right? Like if I take this ray, maybe it's ray AB, and I swing it around and stop it right back where it started, it's going to go through 360 degrees, okay? 1/360th of a complete rotation gives an angle whose measure is 1 degree. Okay, so if I break this up into 360 equal parts, good grief, right? I'd have 90 parts right here. Here's 45 parts, right? 45 degree angle. There we go. It's that 2.5. So, I mean, 1 degree is pretty tiny. I can't even really draw it here appropriately. It's very, very small. 1 degree angle. Okay? Hopefully that's review a little bit. Angles are classified by their measures. All right. Hopefully we remember that as well. This is an acute angle. It's an angle that's somewhere between 0 and 90 degrees. All right, notice that we're using theta to represent our angle. Well, sometimes that's the other thing. If we're not using capital letters, then a lot of times we'll just name the angle and we use it with Greek lowercase letters usually. Okay, we use alpha, beta, gamma. I don't use delta that often because I can't draw that. Epsilon, I don't use zeta. Theta is the main one. I would say theta and alpha and beta are usually the ones that I see used the most. We don't use pi for obvious reasons. Okay, so anyway, that's just there for you to realize where a lot of times we use a Greek letter to represent that. Anyway, a right angle, oftentimes I still am going to show you this opening, which way I opened, but this is a right angle, 90 degrees exactly. An obtuse angle is somewhere between 90 and 180. Somewhere between 90 and 180. Okay, so these are all, if you'll notice, positive angles. And then a straight angle, a straight line, is 180 degrees. Okay, so just angles are classified by their measures. The complement of an angle is the angle that you add to the angle to get 90 degrees. Okay, the complement of an angle is basically 90 minus that angle. Okay, so if I have theta is 40 degrees and somebody asked me what's the complement would be 50 degrees. This only works with positive angles. We're not talking about negative angles with complements and supplements. Okay, they're positive angles. Okay, positive angles that add to 90 degrees are complements. Positive angles that add to 180 degrees are supplements. Sometimes they'll show that in this way. They'll say if theta equals 30 degrees, then what's alpha equal? And you'll have to realize, oh, that's a straight angle, so that's 180 degrees. So alpha must be 150 because they're supplements. Okay, they won't downright say, hey, alpha and theta are supplementary angles, because you're supposed to know that just from looking at the straight line. Okay, so there'll be some problems in your homework like this. Find the measure of each marked angle. Since the two angles form a right angle, I don't know if I told you that, but this symbol implies right angle. If you don't see that symbol, you can't assume it's a 90-degree angle. All right, but since I have that symbol, I know that 6x plus 3x has to add up to 90. Do you see it? Since 6x is this angle, 3x is this angle, and they both together form the 90-degree angle, they have to add to 90, okay? So I know that 6x plus 3x equals 90, 9x equals 90, x is 10. So that a lot of times that's not the final answer. They want to know what each angle is. So if x is 10, this angle is 6 times 10 or 60 degrees, and this angle is 3 times 10 or 30 degrees. Okay, we have to substitute 10 in for x. Okay? Everybody all right with that type? Similarly with the supplementary, okay? Here, 6x plus 4x add up to 180. So we have 4x plus 6x equals 180, 10x equals 180. Divide by 10, you get 18. Now you can't stop there, okay, because, well, it depends what the question's asking. It says find the measure of each marked angle. So you're going to have to go back then and substitute 18 in for x. 4 times 18 is 72 degrees. 6 times 18 is 108 degrees. So this one is 72 degrees, and this is 108 degrees. I don't know if I talked about that symbol much, but the little circle above the number indicates degrees. That's the degree symbol. Okay, I think you know that. Again, from geometry. Okay, a little bit of review. Hopefully this is review, but I know it might be a little rusty. All right, here's something that might be a little new. All right, you know how we have an hour, which is divided up into minutes, which is divided up into seconds. So I can either say 1 1/4 hours, or I might want to say 1 hour and how many minutes that is. That's not 1 hour and 25 minutes, right? An hour and 1/4 is not 1 hour and 25 minutes. What you have to do is figure out 0.25 of an hour, okay? So 0.25 of the 60 minutes that are in an hour. 0.25 of 60, or 1/4 of 60, is 15 minutes. So how many hours and minutes is 1.25 hours? A lot of times people get kind of tricked into saying, oh, that's 1 hour and 25 minutes. No. That's 1 hour and 15 minutes. Okay? Let's go the other way. What if it's given this way? How many hours? I just want to know hours. Don't give me minutes and seconds. Give me a decimal for how many hours is 2 hours, 32 minutes, and 24 seconds. Okay, to do that, I know that 32 minutes is 32/60ths of an hour. I know that 24 seconds is 24/360ths of an hour, 3,600 of an hour, right? We do that math, we get 2.54. All right, gang, I'm running out of time. So I'm going to show you how this relates to degrees, minutes, and seconds.